Okay, question 38 says the value of an antique car is modeled by the function v of x equals 107,000 times 1.009 to the 2/3 x power, where x is the number of years since 2005. By what approximate percent rate is the value of the car increasing per year? Okay, since we have an x in the exponent, that means this is an exponential function. Okay, remember exponential functions come in the form y equals a times b to the x, all right? And we've not seen many this year that do this, but you can also have functions that are y equals a times b to the cx. And what I mean by that is there can be another number up here beside the x, all right? That's all right. In this case, since x is the number of years, it just affects how quickly the growth rate is actually happening, all right? So for our problem, we've got v of x instead of y, which is okay, equals 107,000 times 1.009 to the 2/3 x power. Okay. Now, if you remember the a, and we took notes on this today, and we've taken notes recently. The a, once again, is your starting value. So that means the starting value of this car in 2005, since x is the number of years since that year. That means in 2005, the vehicle, this antique car, cost $107,000. Right? So this is our starting value right here. The 1.009 is the growth rate. Okay. Now, if you're talking about the percent that this car is increasing, the percent rate this car is increasing per year, all right, then you have to realize that the 1, the number at the beginning here, the 1.009, that 1, if you're talking about some type of interest being gained or the value increasing by some percentage, the 1 just keeps the value where it is, and anything after that 1, like 0.009 or 0.06 or whatever it may be, is the percent that value is increasing. Okay, so for instance, if we take out this 1, we're left with 0.009. That ends up being about 0.9%, because remember, to go from a decimal to a percent, you move the decimal over 2 places. Okay, so it will become 0.9%. All right. Now, let's say we plug in 1 for the number of years since 2005. Okay, that means if we were to take 0.9, let me back up just a second. Let me say I take this whole thing right here, 1.009, and let's say we plug in 1 for x. So let's say we're talking about 1 year later. Okay, 2/3 times 1 is just going to be 2/3. So that means we're going to take 1.009 and raise that to the 2/3 power. Okay, so what we would do is we would plug this in our calculator. We would take 1.009 and raise that to the 2/3 power. Okay, and I have to be careful to make sure that I put parentheses around the 2/3 so that the calculator doesn't think that I mean 1.009 to the second and then divide all that by 3. We have to put the parenthesis or the exponent in parentheses when we do this. Okay, and on your calculator, I'm going to write over here, it would look something like this, 1.009, and remember the exponent button, and then you would put 2/3 like that. Okay, and when you do that, you come out with this expression. It ends up equaling 1.00599. Okay, so that's really close to 1.006. All right, so that means every year, all right, when you plug in 1 year, that means that the percent that this car is going, or the value is going to be multiplied by 1.006. And as I said up here earlier, that 1 represents keeping the value where it is, and anything more than 1 represents the percent of increase. Okay, so for 1 year, we plugged in 1. That gave us a rate of 1.006 for the whole year. And so what that means is if I take this 0.006 and change that to a percent like I did up here with the 0.009, then that is going to give me, move it over 2 places, 0.6%. So that means our answer is C. So a little complicated here. That's probably why this question was thrown out, because we've not seen any problems like this year. But if you do see something, that's okay. If it's saying how much is it going up per year, plug in 1 year, see what actually happens to the rate when you raise 1.009 to the 2/3, and that's going to then just take that 0.006 and convert it to a percent, and that gives us how much the car is increasing per year. Now that doesn't seem like a lot, 0.6%, but if you take a $107,000 car and multiply that by 0.006, that means the value of the car is increasing by about $640 every year, okay? At least the first year, okay? So after that, obviously 0.6% of that next total would be a little bit more than $640. So the value goes up, but the percent it goes up is going to be about 0.6. Okay, so the answer is C.